So we'll carry on with the discussion of the production function that we completed in last couple of lectures. Today we are going to discuss about marginal product. To motivate the idea, let's think about the production function of a lumberjack. So as you know, lumberjacks are people who cut trees. And in this diagram or in this picture, you can see there are two lumberjacks who are using a big saw to cut a tree, or to be precise, wood in this case. Now let's discuss the production function of a lumberjack. We all know a generic production function will look something like this, where Q is a function of K and L, where Q is output. In this case, in the case of lumberjack, which may be number of trees they are cutting. F is a function. K is the capital. In case of lumberjack, these are saws. And L is the labor, is the basically the lumberjack. So production function shows you a relationship between saws and lumberjack, and output would be cut trees. So let's try to put this in a different format. Try to put it, create a schedule. So we have here the lumberjacks, which is labor, which is denoted by L. We have saw, which is capital, denoted by K, and their trees are output Q. So trees are nothing but the output, which is denoted by the letter Q. Let's say there is a fixed amount of capital. So capital is fixed, and we all know in the short run generally capital is fixed. In this case, let's say there's only one saw. So I'll just put 1, 1, 1, 1, 1. So all the saws are, there's only one saw is there. So if you're an entrepreneur, you hire a labor. So you hired the first labor, and you realize that when you hired first labor, you are able to cut down 4 trees. So in this case, the production function shows that 1 unit of labor, 1 unit of capital, the person who is able to cut maybe 4 trees in a day. Let's now increase the number of labor. Now I increase the number of labor to 2. Now keeping the capital fixed because there's only one saw, and we saw in the last picture how 2 persons can be more efficient, so they might be able to cut down instead of 4, maybe 6 trees. Let's increase the number of labor to 2, keeping the capital constant at 1. And we saw that in the picture that perhaps 2 persons is more efficient in cutting the trees. So 2 persons with one saw are able to cut down, say, 10 trees. Having seen that, suppose you employ a third person. Now your number of labor goes up from 2 to 3, but capital remains constant. As a result, now you are able to cut down 12 trees. You keep on increasing the labor, 4. Now instead of 12, now perhaps you are cutting down 13 trees. You hire the 5th labor. Again, your capital is fixed. You realize you are cutting down 13 trees. You may ask the question, why, when you hire the 5th labor, why output remain constant? Now you can imagine if the machine, in this case the saw is one saw, only so many people can work on a single saw, right? You really can't have like 5 people working on the same saw at the same time. So it may not lead to increase in output if you just keep on increasing the amount of labor. So this is nothing but a production schedule or production function that I showed you before in a tabular format. Now let's define something which is called marginal product. So what is a marginal product? This is the additional output of one more worker. So here you are asking, if you hire one more worker, how much additional output you are producing? Additional, that means how much extra that person is producing. And often we denote it by something called marginal product, which is nothing but delta Q over delta L. Often in math, this delta means change. So delta Q means this change in Q or output, and delta L means change in labor input, in this case number of lumberjacks. And this measures basically if you increase labor by 1 unit, how much the output is going to change. And that's the idea behind marginal product, or in this case marginal product of labor. So that's why often we put a small l here. It's called marginal product of labor. Now related to this concept, there is a concept law of diminishing marginal productivity, which says that the general rule that as a firm employs more labor, eventually the amount of additional output produced declines. That means as you keep on hiring more and more people, doesn't mean that your additional person is going to produce more. Eventually the rate at which it increases keeps on decreasing. It will be clearer. Let's follow on the example that we did in the previous slide. Initial example where I had again number of labor, capital, saw, fixed, right? Trees is the output. What I'm doing here, I'm calculating the marginal productivity of labor. So when you hire the first labor, that's your first labor, how much your marginal productivity? It's nothing but change in output. So marginal productivity is change in output over change in L. How much is the change in output? Change in output is 4 minus 0 because you didn't produce anything before that. Change in labor is 1 minus 0 because you just hired the first labor. So marginal productivity is 4. So let's keep on doing it. So when you hire the second person, marginal productivity is 10 minus 4 over 2 minus 1, which gives you 6. So marginal productivity is 6. And if you keep on doing it, the marginal productivity for the third worker is 2. Marginal productivity of the fourth worker is 1. And the marginal productivity of the fifth worker is 0. And this is the idea behind the diminishing marginal productivity. As you can see, as you keep on hiring labor, initially it increased from 4 to 6, then it kept on decreasing. And this is where the diminishing marginal productivity of labor kicks in. And that's the reason firms just can't keep on adding more labor to produce more. Eventually they have to scale up, and when they scale up, which essentially means that they have to also buy new machineries. So labor and machines needs to be increased at the same rate just to keep on increasing the production. And that's a very important insight. Otherwise, think about it. If you just keep on increasing the labor, you can produce the food for the whole world from a very small piece of land, but that doesn't happen, right? You can utilize so many people in a single piece of land to produce food. Similarly, for the lumberjack, you can't just keep on hiring more people if you don't have enough saws to cut the trees. So for workers to be productive, you need to provide them machines as well. And often economists use this concept of marginal productivity to understand the productivity of the workers.